Okay, so let's make it more simple. uh, that for example, this is a matrix A, and here we have the vector B, B1, B2, B3. So we will eliminate these elements A21, A31 by 0 with the help of this row. And then if you do some operations on this row, for example, if you multiply this row with A21 uh, and divide by A11, and then you will subtract from the from this one, so this will become 0, and these values will change. They will become some other values, and these values are known as A22 dash, A23 dash, and this value will also change, C2 dash. And then when you will use this row to eliminate this one, so again the same thing will happen, and these values will be changed, and this will give you the solution. From here you have, for example, all these are multiplied by x1, x2, x3. This is multiplied by, this equation is multiplied by x2 and x3, and this equation is multiplied by only x3. So in this equation we will be having only one unknown, and that is x3. And here we have two unknowns, but from this equation you have already the value of x3. You will put the value of x3 from here to here, and you will get the value of x2 like here. And then you will be having the values of x2 and x3, and you will put it in the first equation, and you will get the value of x1. This procedure is known as back substitution, and eliminating all these elements is known as the forward elimination. So let's solve one example, and I hope you will understand much better with that example. I'm also drinking my coffee because I think it will give me some more energy, and you can feel the difference in my voice because by drinking some coffee now my voice has a little bit changed. Okay, so let's solve one example. This is the example. I have placed it here. So we will solve this example by Gauss elimination. We have matrix A, and these are the coefficients of all x1, x2 and x3. I have written in the form of a matrix. This is matrix A and this is matrix E, and now we are going to solve this equation with the help of Gauss elimination. So the first thing that we have to do, we will make this one 0. For example, this is, say, you can call them equation 1, equation 2, Control C, equation 2. Okay, and this is equation 3. Okay, so this is the first set of operation we're going to do. This equation will remain as it is. You can put it here, say, okay, I just copy paste directly from here, but this is not the right way. We should put here the cells, because if you are making an Excel file to solve any set of equation, you should give here the references from the cell. For example, instead of putting 3 here, you should put here the cell number, so that later on if you change this value, everything should change itself. But because I want to save this time, and I have just explained you can do it that way. Okay, but if you're solving an exam and your Microsoft Excel, use this way. I think it's much more efficient and fast. Okay, so this is the first equation. It will remain as it is. So now I want to make this one 0. So how I can make this one 0? I will subtract from this equation this multiplied by, divided by, again 3, multiplied by 0.1, or multiplied by 0.1 and divided by 3. So if I multiply this by 0.1 and I divide by 3, this term, it will become the same as this one, and it will become 0. Okay, so if I press enter, it will become 0, and the same operation you can do it here and here as well. For example, now this minus this equation multiplied by 0.1 and divided by 3. But if you are doing, if you want to make this a general program, instead of writing here 0.1, or instead of writing here 0.1, put here the cell. For example, directly instead of 0.1 you can just replace this by cell, but then you have to do it for every term here, so it will become a general program, but I'm not going to do that. I'm just explaining it to you. Okay, now how you can make this term 0. For example, this equation minus this equation multiplied by 0.3 and divided by 3. Okay, so it became 0, and the same operation we do it here and also here. Okay, so now we can call this is, say, equation 1a, this is equation 1b, or 2a and 3a. So this is the second operation. Now in the next step, what we will do now, all these terms are actually a22 dash, a23 dash, and this is b2 dash, and the same way this is a32 dash and a33. I'm sorry. Okay, so now we are going to eliminate this one 0. So let's say in the new set of equations, this set is we call it as 1b, 2b, and 3b. Okay, so now I want to, this will remain as it is, just control C and then control V. Okay, and this will remain as it is here, just put it here, and then this okay, I think I should just paste the values. Okay, so control C and right click, and you can say paste values. Okay, and these are already the values, no cell operations. Okay, so this is again 0. Okay, now we want to make this one 0. How we can make this one 0? We will multiply, we will subtract. Okay, let's put these values here so it will be easier for us. Paste values. Or if you want to do the direct operation, you can say here this cell minus this cell multiplied by minus 0.19 and divided by 7.00333. Okay, so okay, it's approximately equal to 0. If you want to make it the perfect 0, so the best thing is just put here this cell itself, and here and divide it by, and put this cell, this one, so yes, 0. And whatever operation you have done here, also do the same operation on these as well. For example, this should be equal to 10.02 multiplied by minus this cell multiplied by this cell divided by this cell, so 10.012, and the same thing you should do here. Simple, this minus this cell multiplied by 0.19 and divided by this, so it will become okay. So from here now you can find out the value of now this is actually x3. So how you can find out x3? Now all these coefficients are actually, for example, this is actually 3x1, this is actually minus 0.1 x2 and minus 0.2 x3, and this is 7 x2 minus 0.29 x3, and this is 10.012 x3 is equal to this. So from here, for example, x3, you can find x3 will be equal to 70 divided by this value. So this is actually x3 7, and now you can get x2 will be equal to, now this is x2 is with this one, so how you can find out x2? This is x3, so it will, for example, minus, okay, I tell you how you can find. This is actually this cell minus this cell multiplied by x3, okay, then divided by this cell. Okay, let me check it again, maybe I'm doing some mistake here. For example, this cell minus this cell multiplied by this cell, and then whole divided by 7. Yes, so it is not correct. So now how we can find out x1? X1 we can find out from here. Yeah, now we have, for example, I have, this is equation, this is x3, x2, and this is x1. So now we have the value of x2, we have the value of x3, and we want the value of x1. So how we can find out? Simple, 7.85 minus 0.2 into x3 minus this cell multiplied by x2 whole divided by this cell. So you will get here the values of x1, x2, and x3, and you can see here the denominator or the diagonals are 0, and this is how we use the Gauss-Jordan method. I give you one time to have a look on this. Okay, and now we are going to solve the same question by using Gauss elimination. So what we do in Gauss-Jordan elimination, we convert all these diagonals into 1, the upper values in 0 and the lower values in 0, and that gives us direct the values of x1, x2, and x3. For example, okay, so let me see the values of x1, x2, and x3. Yeah, we have the same values which are here in the questions. X1 is 3 and x2 minus 2.5, and x3 is equal to 7. There are some drawbacks of these elimination methods. For example, we have different sort of errors, round of errors. Sometimes if we divide by 0, for example, if in an equation the two terms become equal to 0 and 0 is divided by some other term, it becomes infinity and the solution is not possible. Again, in the Cramer rule, if we have a singular matrix where the determinant is 0, so we cannot solve it. So there are some improved techniques. So let's talk about the Gauss-Jordan. What is this Gauss-Jordan method? In Gauss-Jordan method, we use elimination, but what we do, for example, in this vector, we make all these diagonals as 1. Like, we will convert this matrix into an identity matrix like this one by using the same technique that we have just studied now. And yeah, so we will convert this matrix into an identity matrix, and we will get the solution directly. For example, what is the Gauss-Jordan method? Let's solve the same example by the Gauss-Jordan method.